In this lesson, we're going to build towards a couple of derivative rules shortcuts. So these are going to be tricks that we can use for harder derivatives that are going to make our lives easier, and we're going to use these the rest of the year in this course. So we can build towards this rule by considering some easy functions that we already know how to work with, right? So we have f and g here, and we're asked to find the derivatives of the following functions. So f of x times g of x, well, that would be equal to the quantity x squared minus 4 times x plus 2. And then f of x over g of x, well, that would be, by the same logic, x squared minus 4 over x plus 2. So you actually don't need shortcuts for these because you already know enough to find these. So what I would do here is I would factor maybe the top here for this particular one, and this would be f of x over g of x, and we want to find the derivative of that. And then similarly here, maybe I would draw a Punnett square to multiply this out if I needed to, and then I want to find f of x times g of x, the derivative of that whole thing. So there is my solution. So notice I did first simplify it up here, and then I did power rule to get that. And then here my x plus 2 is canceled out. Here is my simplified version, and then the derivative of x minus 2 is just 1, right? So this is nothing new, and hopefully you got those both correct on your own. If not, make sure you fix your notes so you have them accurate. We're now going to solve these problems the other way. So these are my new derivatives rules. We have product rule and quotient rule. And luckily, you're beyond the point in your career where I'm going to make you do a bunch of work by hand using the limit definition to prove these rules. But this definition is still where these rules come from, and maybe I'll include a link to the proof here of these in a little note or something. But at this point in the course, we can just assume that this definition is where our rules come from, and we're going to worry about learning how to apply them instead of deriving them. Thankfully, I think, right? So we already know the answers that we should get from these. So notice my functions are the same, right? I have a product and a quotient, so I know I should get 3x squared plus 4x minus 4, and I know I should get 1 for our derivatives here. This will be h prime of x, and this will be k prime of x. But what I think, right, is this work of kind of having to multiply this out is a little bit cumbersome, right? So it would be nice to have a shortcut, a rule that applies to the product of these two functions that can get me the derivative a little bit faster. Especially like these I picked to be pretty easy, but I could pick much longer functions that would be much harder to multiply out, right? So that's what product rule is. Product rule says if I'm taking the derivative of f of x times g of x, that's equal to f of x times the derivative of g plus the derivative of f times g of x. So let's see how that works in practice. And what I like to do here is I like to make a list. So I would first just annotate my two functions. So notice I have just f and g from before. I would just say f, and I would say g. And then I would just make a list of everything I need is how I like to do this. So f is going to be x squared minus 4. F prime is going to be the derivative of f, which is just 2x plus 0, right? G, same thing. So G is x plus 2. G prime is just 1, right? So there's everything I need. And notice I'm using a little bit of shorthand. I'm not writing the g of x. We're using this notation for our notes, right? We don't have to be super formal about it. Then based on my rule here, I need f x squared minus 4 and times g prime, which is just 1, and then plus f prime 2x times g, x plus 2. And this I would call, if this is h of x, I would call this h prime of x, the derivative of h. And then I just distribute. So distributing the 1 doesn't really change anything. So I get x squared minus 4, and then I distribute the 2x plus 2x squared plus 4x. And then combining my like terms, I get 3x squared plus 4x minus 4. And that was what we were expecting to get all along h prime of x. So we've just kind of shown that our rule works, right? So if we use the rule, we get the same result as if we had multiplied it out and just used our power rule, right? Quotient rule, this one's actually probably harder than just simplifying in this case, but we're still going to get the same result, and we'll look at an example a little bit later where we have to use quotient rule and it's useful to us. But I'm going to use the same thing. Notice my rule is a lot more complicated. It says I take my bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. And yes, you will have to memorize this. I still mix these up every once in a while sometimes, so it's okay if you get it wrong. G of x here is going to be x plus 2. G prime is going to be just plain old 1. It's the derivative of x plus 2. And then f here is going to be my top, x squared minus 4. And f prime is just going to be 2x. The derivative of negative 4 is 0. And then I just start to plug it in. So g is x plus 2 times f prime is 2x minus f, which is x squared minus 4, times g prime, which is 1, all over x plus 2 squared. And that is my derivative k prime. Okay, now I just simplify, and notice I have some distribution happening. Boom, boom, and then boom, boom. I'm just going to ignore the 1, and then I can expand the bottom. So I distributed my negative, and on the bottom, use a Punnett square if you're unsure how I got this. Okay, now this looks, remember we were supposed to get 1. I'm actually going to move this down a little bit so I have room for one more line here. And it looks pretty far away from 1, right? But look what happens. This is going to be cool. So when I combine my like terms, I get x squared plus 4x plus 4 over x squared plus 4x, which is 1. So there's my k prime of x. So there's our algebraic examples. We're going to look at an example where we really have to use this rule here in a second. Okay, so here we have h of x is f of x over g of x, but all we know about f and g is that they're graphs, they're little linear piecewise functions here, so we know that they have slopes and they have y values, but we don't know what the formula is for them. And because I have a quotient, the first thing I'm going to do is just write the quotient rule from the front. And I'm going to use shorthand. I'm going to say g times f prime minus f times g prime, like this, all over g squared. So I think like that's useful shorthand to us. We know what we mean, right? Now here's the trick, is I need to pull all of my values off the graph. So the point 7 is right here, x equals 7. So f of 7, if this is f of 7 is obviously going to be 1. Now, f prime of 7 in this case is also 1. And I want you to make this note so you don't forget how we got that, is f prime, right, is the slope of f. So we just pulled the slope off the graph, and I'm doing rise over run on this line segment. I get a slope of 1. And then g, same thing. So g of 7, well, that's down here. That's negative 3. G prime of 7, and I'm going to do rise over run here again. I get negative 1/2. So those are the values we need, right? And then I'm just going to use this formula here, but with my values that I just picked now, right? So I will do h prime of 7 now equals, if I write it exactly how I wrote it before, negative 3 times 1. So that's g times f prime minus 1 times negative 1/2. So that's f times g prime all over negative 3. And then you can use a calculator to simplify this, is fine. Or you can do the math out fractionally. Watch out for your negatives, right? I get here, and it would be good to make sure that you can get this as well. Negative 5 over 18. So it's kind of interesting, right, that my rule, my quotient rule here, works for functions, but it also works if I just go through and plug in numbers, as long as I'm using the values at this x equals 7 that I'm interested in.